Every morning, as we wake up, the first thing our eyes fixate upon is the sky above us, a vast canvas painted in a deep, tranquil blue. But have you ever paused to seriously ask yourself, why is the sky blue? This beautiful color is not a simple accident or a mere divine design. It is a complex and precise physical phenomenon involving billions of instantaneous collisions between light and matter. Today, we are going to unlock the secret behind this deceptively simple question and journey into the invisible world of subatomic particles and the fundamental laws that govern light. To find the answer, we must first understand two things: how light works and what our atmosphere is made of. To truly understand the color of the sky, we must first become intimately familiar with our two main actors, sunlight and the Earth's atmosphere. The light we perceive as white or golden from the sun is not a simple ray. It is a complete spectrum of the 7 visible colors of the rainbow, each possessing its own unique physical properties. If this light passes through a prism, we can see the full spectrum from red to violet. Wavelength. The most crucial property of each color is its wavelength. Longer wavelengths, colors like red, orange, and yellow, travel in longer, slower waves. They carry less energy. Shorter wavelengths, colors like blue, indigo, and violet, travel in shorter, faster waves. They carry higher energy. Our second actor is the Earth's atmosphere. The air we breathe is not empty space. It is a dense soup of trillions of gas molecules, predominantly nitrogen, 78%, and oxygen, 21%. Here lies the main secret. These molecules are incredibly tiny. Their size is approximately 10,000 times smaller than the wavelength of visible light. This minute scale is the key to our entire phenomenon. As the sun's light beam, traveling at its astounding speed, hits the boundary of the Earth's atmosphere, it immediately begins to collide with these billions of minute oxygen and nitrogen molecules. This is where the magic of physics takes over. This phenomenon is called Rayleigh Scattering, named after the British physicist Lord Rayleigh. Rayleigh Scattering states that if the particle the light hits, the air molecules here, is much smaller than the light's wavelength, the particle will scatter the shorter wavelengths, like blue and violet, much more efficiently and intensely than the longer wavelengths, like red and orange. Think of these tiny molecules as millions of miniature mirrors that are perfectly tuned only for blue light. The red, orange, and yellow light, long wavelengths, mostly continue straight toward Earth, but the blue and violet light, short wavelengths, are instantly absorbed by the molecules and re-emitted in all directions across the atmosphere. You might logically ask, if Rayleigh scattering efficiently scatters both blue and violet light, why don't we see a violet sky, given that violet has the shortest wavelength? The answer involves two factors: solar intensity. The sunlight itself contains more blue light than violet light to begin with, and human eye sensitivity. More importantly, our eyes are significantly more sensitive to the color blue than they are to violet. The color-sensing cells in our eyes, cones, are much more effective in the blue region of the spectrum. Therefore, when we look up, the light reaching our eyes from every direction is an abundance of blue light that has been effectively diffused by the air molecules above us. We are in effect looking at light that has been indirectly bounced down to us from every point in the sky. And that is the calm, definitive color, blue. Now that we understand the secret to the daytime blue, we can explain two other powerful visual phenomena in the sky: the warm, fiery colors of the sunset and the clean white of the clouds. These two are logical consequences of the laws of light physics. During the day, the sun is high overhead and the light travels a relatively short distance through the atmosphere. But at sunset or sunrise, the sun is near the horizon. Longer path. In this position, the sun's light must travel an extremely long and thick path through the atmosphere to reach our eyes. Total filtering. Along this greatly extended path, the countless air molecules sequentially and intensely scatter the blue and violet light. Virtually all of these shorter wavelengths are completely filtered out and dispersed before it gets to us. Therefore, at sunset, the sky bursts into these warm, fiery hues. The more particles, like dust or pollution, in the air, the stronger this filtering effect, making the sunset more dramatic and red. Why do clouds, existing in the very same atmosphere, appear white instead of blue? The answer lies in particle size. Much larger particles. Clouds are formed of much larger water droplets and ice crystals, particles that are significantly larger than the wavelength of visible light. Scattering occurs. When particles are larger than the wavelength of light, Rayleigh scattering no longer applies. Instead, scattering occurs. Larger particles scatter all visible wavelengths, red, orange, blue, etc., equally. Equal reflection of all colors combined results in the color white. This is why clouds appear clean and white against the backdrop of the blue sky. Thus, the blue color of the sky is not merely a pretty sight. It is a logical and marvelous consequence of a fundamental physical phenomenon known as Rayleigh scattering. This intricate dance between sunlight and the atmosphere's tiny molecules is a potent reminder that the greatest and most calming beauty in nature often stems from the simplest and most precise scientific principles. Physics truly is the canvas of our world. Every time you gaze into the blue sky, remember that in that moment, billions of nitrogen and oxygen molecules are diligently scattering blue light to create that magnificent vista just for your eyes. If you enjoyed this deep dive into the physics of light and color, please give this video a like and share it to support us. Let us know in the comments below which other natural phenomenon, like rainbows or the aurora, surprises you the most. Be sure to subscribe to our channel and hit the bell icon so you don't miss any of our next compelling stories on science and nature.